Yeah, thanks everybody for coming. I know it's just after lunch, so I'll try my best to not to help you fall asleep. I'll try to make this somewhat interesting. A little bit higher? Oh.
I'm boosting.
Oh, thank you.
Just keep talking.
Okay, thank you. Is that better? Louder? All right, I like this audience participation. Thank you. All right, and for those of you in the back, we still have some seats if you want to come in. So yeah, thanks everybody for coming. Thanks for coming to Dev Summit and for choosing to come to my talk after lunch. So this is the ArcGIS API for JavaScript. We're going to be creating custom layers and layer views. And my name is Jacob Moselkowski. So this is going to be a pretty short talk, maybe about 20 minutes or so. I am trying to pack in a lot of information into the slides so they can be referenced for you later. But you might want to grab a picture or write down this one because I do have these slides available on a GitHub repository. So that's github.com/ my username jwazelgeo, because my last name is way too long to not shorten, jwazelgeo/presentation. So you can find the slides there if you miss anything. So if you feel like I'm going too fast, don't worry about it. I just want to pack in a lot of information that you could look at later on your own time. So I'll try to introduce you to the parts of the ArcGIS API for JavaScript, which I also call JS API, and what that means for you as developers if you want to make custom layers or layer views. I'll show you a few examples of custom layers that are out there, and then I'll do a deep dive into an app that I made called Earth at Night, Mountains of Light, that has a custom elevation layer. So if you're going to be extending layers and layer views in JS API 4x, the core team has sort of split up a few different concepts called layers and layer views, and as a secondary kind of item, external renderers. So here again, for your reference later, I'm just listing some of your entry points as developers. You've got base dynamic layer, base elevation layer, a tile layer, and then for those of you making custom layer views, you've also got a couple modules there that have long names that I'll skip reading right now. And then finally, if you're really into WebGL and you want to do crazy stuff in 3D, then you have this option of using an external renderer. But I know nothing about WebGL. It actually terrifies me. I'm not going to talk about it today. So if you're someone who wants to make a custom layer, what that means in this newer version of the JavaScript API, they treat the concept of, I guess, data and the view of the data as two separate things. So a layer really ultimately is about data access and data storage. They don't typically have a direct visual representation in a map view or a scene view. But they're typically used for things like tiled layers and images, but you can still jump into these and do custom stuff with JavaScript. So you might want to use a custom layer or write a custom layer if you want to access a GIS service that isn't necessarily out of the box supported yet with the JavaScript API. You might want to manipulate some pixels of an image before they get rendered eventually in a map view or a scene view, or you might want to even like combine two or more GIS services into one layer to make something unique. And I'll show you a few examples of that. So the concept of a custom layer view, which is only for 2D map views, it's really, it gives you a lot more power, but it also gives you more, I guess, responsibility and work to do. But it can be really fun and powerful because in a layer view, you're actually going to be writing custom canvas commands or WebGL commands to make literally anything you can dream up. And in this case, you aren't going to be limited to a tiled kind of a layer. You can actually do anything else you want to do. And again, if you really want to go crazy here and you know WebGL, you can use an external renderer if you're going to be in a scene view. So with those walls of text aside, again, they're just for you for later. The actual official documents have a lot of great samples of custom layers, so I'll show you a few of those in my browser here. On the left here, there's a whole section of custom layers that you can look at yourself. So in this simple example, they've taken Some of you may know this Stamen toner base map, the like really pretty black and white base map of tiles, and they've added a few extra canvas commands to manipulate the colors before they get rendered in a scene view. So this sample just walks through how you can do that, and as I said, there's a handful of others that I recommend you looking at. They're pretty cool. And so those are mainly examples of custom layers, but with a custom layer view, a good friend of mine and a colleague who's a cartographer at Esri named Sarah Bell and I worked together to make a custom base layer view 2D. So we're no longer tied to just, in this case, we're no longer tied to just customizing tiles that show up in your browser, but we're actually making custom visualizations that aren't tiled. So I'll pull that up and show you that. So I recommend you also check out the GitHub repository. You can plug this in and use it yourself in a 2D map view. It's called the Canvas Flow Map layer, and it's about mapping the flows of objects. So it could be the flows of from origins to destinations, the flows of objects or people or ideas. And we're not relying on any kind of custom tiling here. We actually, as I'm mousing over these different origin points, you can see the many destinations that are connected to that origin point. And what's happening as I'm mousing over is my custom layer view code is executing with canvas Bezier curve commands from these origins to destinations. So it gives you a lot of power, but it also asks you to do a bit more work with your custom code. But again, everything's on GitHub, everything's documented pretty well. You have to do a bit of work, but you have a lot of power over what you can make here. So I think at this point I might just slow down a little bit and enter the third part of my talk, which is a deep dive into this Earth at Night Mountains of Light application that I made. So I'll pull that up and show you a live demo of that. And I promise we'll get to some code soon. So I found a NASA tiled image service that shows Earth, the Earth at nighttime and the light emissions from human developments. And so what I did here is I'm taking the intensity of the light emissions coming out of nighttime lights, which really is just a flat kind of tiled image service of the Earth, and I'm using the idea or the concept of brighter lights create higher elevations. So I just wanted to pull mountains up off of the surface of the Earth in a scene view, and higher mountains indicate higher concentrations and brighter lights coming from more, I guess, dense and bright cities around the Earth. And so if we just find our location, let's go over to where we are and take a look at how that looks. So when I zoom out, it looks like a typical flat image service or tiled image service. But again, as I zoom in and I sort of move my camera down at a different angle, I see these exaggerated terrain mountains. And they're not driven at all by physical mountains. They're just driven by bright city lights. So if you do want to play with it yourself, I've got the link up here. I will go into some of the details of how this is made. And it primarily focuses on a custom base elevation layer. So in this case, I am interested in tiles and doing custom things with tiles. In this case, they're elevations. And I'm telling my scene view that I've got a custom elevation layer that I want to represent with these fake mountains. So what I think was sort of neat, I actually was inspired by 3 official sample documents that helped me come up with what I wanted to do. So I think this is a good story for yourselves too. If you've got some ideas that you're thinking of and custom things you want to make, I really strongly recommend looking at these sample documents to get ideas and then mash them up together yourself. So one out of the 3 samples that helped me was one that takes Esri elevations, the Esri World Elevation Service, and just exaggerates terrains. So these terrains are greatly exaggerated. If I zoom in, you can see these. I mean, it's comical and a bit absurd, but it's not really that much code to pull this off. It's sort of intercepting the elevation, the true world elevation layers, right before they get rendered in a scene view, and then multiplying them by a huge number. Another great sample that's out there is using thematic data as elevation, which is exactly what I needed. I have this thematic nighttime lights data, right? It's tiled, and I want that to drive my elevation. In this case, this sample uses sea temperature to create fake mountains across the world. And finally, this is more of window dressing. It's just an add-on. It's not a custom layer, but I use this sample to help me create call-out lines with labels to help me achieve a feature layer, actually, that I'm adding after the fact to label my cities like I am here. So I want to sort of break this down into three main steps that I took with my code to make this happen. And I'll flip through a few slides so you can see the progression, then we'll go back and walk through some of this. So in step 1, I'm not really actually making a custom layer. I'm using the JavaScript API web tile layer, which lets me point to any tiled image service or any tiled base map service that has an X, Y, and Z in the URL. And that lets me just point to this other NASA third-party light layer, nighttime lights layer. And I've just put that on a scene view. And then in step 2, I actually created a custom base elevation layer that's driven by that NASA web tile layer to pull those brighter pixels up into the sky. And also use a third-party Chroma.js library, which is a lot of fun to help me turn my pixel color values into elevation heights. And finally, I tossed in this elevation layer with the call-out labels. So I'll go back to step 1 and just show you how some of that looks. So just for proof that I'm not lying to you, here it is. Nothing special here. There's not really any elevations going on here. It's just the NASA nighttime lights tiles being drawn around the world. And the code for that is, again, very straightforward. I'm using a web tile layer, and I'm including the NASA URL, and then I'm simply adding that to my scene view. I put the construction of this web tile layer into a function because later I knew I'd need to reuse this web tile layer function a few times. So it's wrapped up in a function, but it's really nothing complicated going on here. And just as an additional fact, I'm manipulating some of the levels of detail because through some trial and error research, I realized that the NASA zoom levels aren't supported at every single possible zoom level. It's only supported for a few zoom levels. So this is just some extra code that you don't need to really pay attention to now, but I'm just manipulating the level of details there. And then I just toss my custom web tile layer from NASA into a base map layer. And that's it. So for step 2, which is really where the magic comes in and sort of pulls these things up off the ground, I'm still using the web tile layer to help me out, but I've brought in the base elevation layer. I've brought in the base elevation layer from the JavaScript API. And the way that looks at a really high level is that I create a base elevation layer. I call the command create subclass to tell it that I'm going to do something custom here and create a brand new base elevation layer class. And after some trial and error, I realized that my exaggeration factor of this crazy high number of 85,000 was just from visual trial and error until I saw that my mountains were high enough. And we'll come back and use that number in a bit. But the base elevation layer, you can define a load function, which is where everything begins. And I also have to create an instance of that NASA nighttime lights layer. So again, then I have to do some manipulation of the tile infos because I have to worry about some zoom levels, but you don't have to worry about that right now. The point is, in this load method, I am, again, creating an instance of this web tile layer pointing to that NASA endpoint. Because in the base elevation layer's fetch tile, where the magic actually happens, this is where I have to manually tell my code that I need to do something with that NASA tiled image layer. So here, this is where the concept of a custom layer shows its I guess you'd say its simplicity And it makes your life a lot easier if you're only thinking in terms of tiles. So you don't really, as a developer, have control over when a scene view is going to call this fetch tile method. You can just assume and know it will happen many times as you're panning and zooming and moving your camera around in a scene view. So every time the scene view comes into your fetch tile at a particular zoom level, a row, and a column, I'm turning right back around and going out to that NASA service to get that tiled image for that zoom level, row, and column. And then when that comes back to me in the form of an HTML image element, I jump through a few small hoops to go from an HTML image element. I just sort of jump into a canvas and back out of a canvas, then finally on line 94 to get to image data. And what this means is it's a huge array of the red, green, and blue colors for every single pixel that came from that image element. So this is sort of a convoluted way of saying I've fetched just an image from some third-party service. I've then taken the pixel information of the pixels of every single image. I've pulled them out, and I'm about to do something with them. So I'm going to loop here over every single pixel in my for loop, and I'm going to grab, for every pixel, the red, green, and blue, the RGB, and using that other third-party JavaScript library called ChromaJS, I convert the RGB pixel color to a luminance. And this is really this is where most of the work happens, because I needed to go from an RGB to just a 0 to 1 value. So let's say in those nighttime lights that you saw, sort of a black, kind of really dark blue color, where it's there's less light emissions. I wanted that to be represented as the number 0. And this is exactly what it's doing for me. And those really bright yellow, white pixels, I wanted them to be representing values closer to 1. And so I end up, for every colored pixel, I end up with these 0 through 1 values, which is great. But 0 to 1 heights of mountains doesn't do much for us if we're viewing something. So that's where that exaggeration factor comes in. I just do a simple multiplication to really exaggerate those 0 to 1 values. So if I ended up with a 0.75 luminance, as they call it, I'm really creating a fake height of 63,000 plus meters in the sky. So at the end of that, I end up with an array of these crazy, fake, exaggerated pixel values, and I return them as is required and defined in the documentation. And then I just hand it off to the scene view, and it does whatever it's going to do to render that. And in this case, in the scene view, I have to rely on that NASA tiled endpoint twice, right? Because on one hand, I need to set it to my ground elevation to pull the scene view surface up into the sky. And I also need, secondarily, to sort of drape it over as my base map over those fake mountains I've created. And then finally, in step 3, where I've thrown in a feature layer with labels, again, just going back and forth here. It's not a custom layer, but it's a feature layer pointing at an ArcGIS Online service I found with cities information, and I've set some labeling parameters to create these callouts that stick up. And so then it's pretty straightforward how it builds on top of itself. The feature layer, if I expand the code for that, there's a lot in here, but there's nothing custom per se. I'm just defining a lot of labeling and rendering properties to get that callout style. And all this code is available online, and again is referenced in the slides if you want to take a look at it. So that was step 1, nothing custom there. Step 2, pulling it up with a custom base elevation layer. Step 3, labeling cities. And that's more or less it. So at a really high level, that base elevation layer, I relied again on the load method and the fetch tile method to do my work, and the ChromaJS other third-party library to help me go from RGB color values to 0 to 1 values. And yeah, even more links for you for later. I've got an extended blog post about this. These slides are available online. Last year's Dev Summit talk was really fun and interesting. Had a lot of cool examples too about custom layers. And also there's some other official documentation there. So I think in the same room tomorrow, roughly around the same time, if you want to go crazy and get into WebGL and do stuff in 3D and actually WebGL in 2D, you can come here tomorrow at the same time and see 2 talks. And that about wraps it up. So thank you. And yeah, thanks for coming here and digesting with me. Oh yeah, I welcome questions. Sorry, yeah, if you have questions, by all means.
So I noticed that to do subclassing in the API, you call that a create subclass factory. If we were using TypeScript or something like that, would TypeScript's built-in extension functionality work, or should we always use the factory?
Yeah, so if I understand, the question was about. The create subclass? Yes, you're right. I'm not using TypeScript here, but your question is if you are using TypeScript, can you use the extending syntax? I'm not sure. I don't do too much TypeScript. I think it might work. Actually, last year's slides on the same topic, there was one section that was all in TypeScript. So yeah, I'm not sure. I would defer to those last slides. Yeah, it should be possible though. Sorry.
One last thing, it's probably in there, but when you override the default method, do you explicitly have to call it superclass?
When you override the default method, you have.
When you override load, do you have to call superclass load?
I'm not sure. I'm not sure if you have to. I'm not sure about that, to be honest. And that would be in TypeScript if you're doing that? Or in any case?
I'm not the best when it comes to prototype objects, but I assume if you want the default behavior and then you drop on top of it, would you call it a superclass extension?
I'm not sure if you have to call a superclass. I know, at least in this very specific case, I'm using I don't know. You may not have to, but I know that I'm following documentation pretty closely here, just to do these specific things. And if I don't define anything in fetch style, I won't do anything. But as far as at the language level, I'm not sure about that. Okay, thank you. Sorry, was there a question? Oh yeah.
With a feature layer, could you do sort of a similar thing with jam your own attributes onto the data as it's coming in? Because we want to jam attributes on that don't exist server side.
Yeah, you could do that, but and that's about jamming in attributes and then doing something with those attributes. Yeah, if you do want to go as far as creating a custom feature layer, then you would actually do that brief demo I showed about the canvas flow map. That would be more about feature layers rather than these tiled things I've focused on. And that's called the base layer view 2D, I think. But you would start there, I think, with jamming in your own custom attributes and then doing something with them to drive your custom visualization, I think. Yeah. Yeah, sure, yeah.
Are slides for all talks going to be available on that GitHub repo?
For all talks around?
Yeah.
The slides for all talks should be available on the Esri proceedings page. Yeah, and I'm not sure if that'll be like next week or in a few weeks. It'll be soon. Yeah.
And they have it for previous years?
Yes, previous years are available too. Yeah. Yes, sir.
Are your feature layer labels tied to the units that you come or the elevation? Or are they just purely cities?
I think, sorry, can you ask your question again, sir?
So the feature layer you have for your elevation markers, or your markers for cities, is that bound to your elevation, the one that you calculated, or is that just purely random cities or just by population or something?
It's just a random unrelated cities layer that I found
So
on
they're
ArcGIS
not
alone.
bound, right? So you're not binding the higher luminance plus your elevation factor you have bound to some variable of city name.
That's correct. Yes, the custom feature layer with the city labels that you saw is completely unrelated to the heights and the custom. Yeah, they're just an unrelated feature layer I found
I'm
online.
assuming you could customize the feature layer to do exactly that. You're saying based on values calculated for elevation, show those labels for the cities.
Yeah, yeah, you could. Yeah. Cool. Yeah. One more question.
I tried to use this before, but my campus always get tainted, like crossover between resources. So your get image data normally gets disabled. Do you have some kind of workaround for taking data from the campus?
Yeah. Let me come chat with you in a second here. I'll let the next guys start talking. All right. Thank you, everybody.